Hey guys, so our lecture series will be covering the 1.2 module of the GCSE curriculum. It will cover the atom, the periodic table and reactions. So our first lesson is all about the atom. The learning objectives for today will be to know charges in the atom, inside of the atomic nuclei, relative masses and charges of the subatomic particles, why atoms have no overall charge, identifying the atomic and mass numbers, how the subatomic particles relate to the atomic and mass number, and finally, defining isotopes and calculating their relative atomic mass.
What atoms are made of? So, the atom is the basic building block of all matter of the universe. Atoms compose of three smaller subatomic particles called protons, neutrons, and electrons. An atom consists of a small region in the center that contains protons and neutrons, and it's also surrounded by shells, and within these shells you can find electrons.
Relative masses and charges of subatomic particles. As you can see from the table, both protons and neutrons have a mass of 1. Electrons have a mass that is so small we just give it a mass of 0. The charge on a proton is +1, and neutrons have a charge of 0, and electrons have a -1 charge. The atom's mass comes mostly from the mass of protons and neutrons, as electrons' mass is 0. Atoms have no overall charge because there is equal number of protons and electrons in an atom, and their charges cancel out. Each positive proton in the nucleus is cancelled out with a negative electron. Neutrons don't contribute to the overall charge as they are neutral.
The atomic number and mass number. We are going to look at helium as an example. The atomic number represents the number of protons in the nucleus, and it also represents the number of electrons in the shells. Mass number is a sum of number of protons and neutrons in the nucleus. Looking at the atomic number of helium, it means we have 2 protons and 2 electrons. So looking at the mass number, we have 4 protons and neutrons in total. From the atomic number, we know that helium has 2 protons, so 4 minus 2 would be 2, which means 2 neutrons. So helium has 2 protons, 2 electrons, and 2 neutrons.
Now that we have looked at and understood the atom, we are going to look at isotopes and relative atomic masses.
Isotopes. Isotopes are elements that have 2 or more different forms of the element, which have the same number of protons but a different number of neutrons. As there is an increase or decrease in neutral subatomic particles, neutrons, the element has a higher relative atomic mass, but all the chemical properties remain the same. For example, if we look at chlorine-35 and chlorine-37, they both have the same atomic number, which suggests the same number of protons. However, they have a different mass number, which means it has different number of neutrons.
We are now going to work through calculating the relative atomic mass. So the relative atomic mass is calculated using this equation. The relative atomic mass is relative isotopic mass times by its abundance, plus the second relative isotopic mass times that abundance, all over the total abundance. So let's work through an example. Relative abundance of chlorine-35 is 75%, and the relative abundance of chlorine-37 is 25%. What is the relative atomic mass of chlorine? Pause the video and see if you can work it out. So, relative atomic mass. Starting with chlorine-37, we are told it has an abundance of 25%. So, 25 times 37. Then, looking at chlorine-35, we are told it has an abundance of 75%. So we add 75 times by 35. The total abundance would be 75% and 25% added together, which gives us 925 plus 2,625 all over 100. That equals 3,550 over 100. So our final relative atomic mass would be 35.5. If you look on the periodic table, we see the chlorine does have a mass of 35.5. That concludes our first video. We hope you enjoyed and followed along. Join us for our next instalment, which would be on the periodic table.